In this lesson, we're going to learn how to simplify rational expressions. And now, recall in the previous lesson, we looked at rational expressions that contained monomial factors. So you may need to go back and review that lesson. So for example, see, in the previous lesson, we looked at simplifying rational expressions where all of the factors were monomial factors. Okay. Now, in this lesson, we're going to look at expressions where they're not necessarily monomial factors. But let's kind of review something first before we go on. So recall that if I want to simplify this expression, so let's say I had 7 times 6 times 4 divided by, let's say, 8 times 3 times, let's say 11, okay? And so basically what you did when you simplified this was you looked at each of the factors in the numerator and see if you could reduce it with any factors in the denominator, right? So if you look at 7, I can't reduce with any factor that's in the denominator because none of these factors have a factor of 7. If I look at 6, I can reduce 6 with either the 8 or the 3 if I wanted to, because both 6, if I look at 6 and 8, they both have a factor of 2 in common. If I look at 6 and 3, they have a factor of 3 in common, right? Okay, so what many students will do is that they'll probably do these two. So they'll say 3 and a 3 is 1, 3 and a 6 is 2. And if you look at 2 again, you can say, well, that 2 will reduce into this 8. That's true. And some students will look at this 4 instead and say, well, that 4 will reduce in this 8, and that's true instead as well. And then some of them will say, well, hey, 2 times 4 is 8, and 8 divides into 8. That's true as well. All right, so there are many ways in which you can reduce these factors, some different ways of thinking about those. All right, so 2 into 2 is 1, 2 into 8 is 4, and then 4 into 4 is 1, 4 into 4 is 1. And that's about all you can do. So you have 7 times 1 times 1, which is 7, divided by 1 times 11, which is 11. All right, so you get 7 divided by 11. So then that takes us, now notice though that these were monomial factors. Okay, so that takes us to what we want to look at today. So now the directions will say simplify. And so if you look at number 1, we have x times x plus 3 times x minus 4 divided by 5x times x plus 3 times x plus 6. Okay? All right, so we have this rational expression, and I want to simplify. Okay? Now, to simplify rational expression, notice that all of these are listed as factors. So x is a factor, x plus 3 is a factor, x minus 4 is a factor. In the denominator, 5 is a factor, x is a factor, x plus 3 is a factor, x plus 6 is a factor. All right, so you want to reduce factors just like you did here, So if I look at the first factor, my first factor is an x. Well, that factor of x reduced with any factors down here. Do I see a factor of x listed anywhere? Now be careful, don't say you see it here, because that right here is a factor in itself, x plus 3. So x is not a factor here. X is a term of a factor, but x is a factor here. So I can reduce these. So let me go ahead and kind of rewrite this. So I get x times x plus 3 times x minus 4 divided by 5 times x plus 3 times x plus 6. All right, so these factors of x divide out. And again, that kind of takes us to our discussion in the previous lesson. See where we had factors of x that I could divide out. And so that's what you saw here. All right, so that same idea applies. Now let's get the next factor. So you got to know what your factors are. So my next factor is x plus 3. Well, that factor reduced with a factor down there. Do you see an x plus 3 in the denominator? Yeah. So you have 1 up here, 1 down there, so those divide out. Okay? My next factor is an x minus 4. Do you see a factor of x minus 4 in the denominator? No. So you're done. You just rewrite your answer as a product of factors and leave it as one rational expression. So 1 times x minus 4 is x minus 4. Notice I did not put parentheses there. Okay? 5 times 1 times x plus 6 is 5 times x plus 6. All right, now let me kind of make a remark here. We tend to write our final answer in factored form. So leave in factored form. Okay, so this is in factored form, which means this: don't distribute. Don't distribute. Now, there's nothing wrong. So if you wrote this as x minus 4 divided by 5x plus 30, that's fine. Okay, but we tend to write it in factored form. So if you went further and you messed up, you made an error somewhere, then you're going to lose points. So even though you had the correct answer here and you distribute and you get an error, you're not going to get full credit. So you'll notice that when you look at My Math Lab, when you do My Math Lab will say, write your answer in factored form. Leave your answer in factored form. Okay, so if it says factored form, okay, and you write this, they may mark it wrong. So if it says in factored form, make sure you follow directions. All right, so always leave answers in factored form. Now, so that was number 1. Okay, so it wasn't that bad. Okay, number 2. Number 2, let's suppose we had negative, and then my numerators will be 18m cubed n divided by 3m plus 21n. Okay, all right, so that's what I have. I want to simplify this. Okay, so if you look at the numerator, those are monomial factors. All right, just like you learned in the previous lesson. We talked about monomial factors in the previous lesson. But those are monomial factors in the numerator. The denominator, though, that's a binomial. All right, so now let's start talking about some steps, so to speak, in simplifying rational expressions. So the first thing you want to do, so let's talk about steps. So these will be steps in simplifying rational expressions. Okay, so first thing you want to do is to, number 1, factor the polynomials. All right, factor the polynomials. Okay, now, so then if I go back to our example, now this is a monomial factor, so there's nothing you can do with that. Leave monomial factors as monomial factors. But see this polynomial down there, that binomial, what do they have in common? So you want to factor this. So the GCF is 3, right? Okay, so that becomes negative 18m cubed times n divided by, and I can factor out a 3, so I get 3 times m plus 7n. Okay? And then once you factor your polynomials, the next step is to reduce. Divide out common factors, things like that. Okay? All right. So that's this idea we did here, where we divided out common factors. So if you look at this, my factors in the denominator is 3, and the other factor is m plus 7n. All right. So if you look at 3, will that 3 reduce with a monomial factor up here? See, that's a monomial. Will that 3 reduce with a monomial factor up here? Yeah, the 3 reduced in 18. So look what I'm going to do now. I'm going to say 3 into 3 is 1, 3 into 18 is 6. Okay? Now look at your next factor that you see down here, m plus 7n. Do you see a factor of m plus 7n in the numerator? No. So you're done. That's all you can do. You've taken care of all of those factors. You've simplified. And so your answer is going to be negative 6m cubed n divided by m plus 7n. That's your answer. Okay? All right, number 3. Let's suppose that number 3, oh, and by the way, and then we'll come back and fill this out in a little while. So first thing you do is factor polynomials. The second step is to reduce. Okay? Now, I'm going to come back and write a couple of things, and then we'll go back to this one as well. All right, number 3. Let's suppose we had number 3. We had 6y squared minus 21y divided by 2y minus 7. Okay? All right, so remember the first step you're going to do is to factor your polynomials. So if we look at the numerator, those two terms, I can factor out, it looks like I can factor out a 3y, right? 3y. So I get 3y times, and then that's going to be 2y minus, and then 3y times 7 is negative 21y divided by 2y minus 7. And that's all you can do because you cannot factor 2y minus 7. Okay, so that's the first step. Factor your polynomials, and I did. So I factored completely, okay? I factored completely. Okay, now the next step is to reduce, divide out common factors. So if you look at your first factor here, and most students can see right away that these divide out, right? Okay, but let's do a little talking. I have a factor of 3 here. I have a factor y, and then here's the other factor. So if you look at the numerator, there are 3 factors. 1, 2, 3. If you look at 3, will 3 reduce with a factor down there? Do you see a factor of 3 anywhere down there? No. Do you see a factor y? Don't say this because that's not a factor here. That's part of a factor. Okay, that is your factor. All right, so be careful. Now over here, you have a 2y minus 7, you have a 2y minus 7, so those divide out. Now here, this is what some students make a mistake with. They just cross it out and without thinking what's really there, and at some point it could hurt you. So what I want you to do is when you cross this out, know what it means, and that's that discussion we had earlier in the previous lesson, that when you cross it out, that means that any factor divided by itself is 1. That's what that means. You get factors of 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So that's what these ones here imply. So 2y minus 3 divided by itself is 1. 2y minus 3 divided by itself is 1. And so now the next thing is going to be, see how I have a bunch of products here? Okay, so the next step is to multiply the remaining factors, or let me write it this way. Write the remaining factors as a product. As one rational expression. Okay? So write the remaining factors as a product as one rational expression. So in other words, you're going to say this. You're going to say 3 times y times 1 is 3y divided by 1, right? But I need you to go further. Don't leave it like this because we all know that 3y divided by 1 is 3y. So that's what you need to write, 3y. Okay? All right, so that's what that is. All right, number 4. So let's go to number 4. So number 4, let's suppose we had this for number 4. We had x squared minus 7x divided by x squared minus 4x minus 21. All right, so what's the first step? All right, well, the first step is to factor your polynomial. So we're going to factor the numerator and we're going to factor the denominator. So that's why in the last module you spent a lot of time at factoring, because what you learned in the previous module is needed throughout this module on rational expressions and equations. So if I factor the numerator, the GCF here is x. I can write this as x times x minus 7. If I factor the denominator, the GCF here is 1. It's a trinomial, so I'm going to go ahead and do the 2 binomials. All right, and so I get x, and I'm trying to get negative 21 and a middle term of negative 4x. So it looks like what's going to work will be x minus 7 times x plus 3. And so let's double check. The outer is 3x. The inner is negative 7x. When I add them up, I do get negative 4x. And negative 7 times a positive 3 is a negative 21. Okay. Now the next step is to, remember, once you factor, step 2 is to reduce, divide out common factors. So my first factor is an x. Will that x reduce with any factors down here? No, because that's an x minus 7, that's an x plus 3. So it's very important you know what your factors are. The next factor is x plus 7. Will that reduce with a factor of x minus 7 down there? Yes, I have one right here. So I have 1 up here, 1 down there, so they divide out. Make sure you put 1s in their place. It's important. It's important you put factors of 1. That's what you see. That's what you have left. And now, once you reduce, I can't reduce anything else, then step 3 says to write your final answer, one rational expression, as a product of your factors. So x times 1 is x. 1 times x plus 3 is x plus 3. And so that's your answer. Okay? Number 5. Let's suppose number 5 we have this, and we have this for number 5. Let's say we have ax minus ay minus bx plus by divided by ax minus ay plus bx minus by. All right. So notice that to factor the numerator and the denominator, those both contain 4 terms. And so remember, when you have 4 terms, you want to try factoring by grouping, right? So let's go off to the side. I'm going to go off to the side here since I'm going to need more work. So I'm going to go off to the side, and I'm going to rewrite the numerator just like this. And then I'm going to group the first 2, and then I'm going to group the last 2. And when I group the first 2, I can factor out an a, and I get a times x minus y. When I group the second 2, remember you got to factor out the negative symbol, the middle term, the middle sign here. So it'll be negative b. And be careful, remember when you factor out a negative factor, be careful with those signs. So a negative b times x is a negative bx, and a negative b times a negative y is a positive by. And then notice I can factor out an x minus y. So I get x minus y times a minus b. So that's your numerator. So my numerator will be x minus y times a minus b. Do the same thing with the denominator. So let's go off to the side and kind of figure out what this one will be. So I have ax minus ay plus bx minus by, right? And so I'm going to group the first 2 and the last 2. In the first group, I could factor out an a, and I get a times x minus y. In the second group, I'm going to factor out that positive sign here, so plus, and then the g-self here is b, so I get b times x minus y. Then I'm going to factor out the x minus y. So I get x minus y times a plus b. So that's going to go here. So x minus y times a plus b. And now, so we did step 1. So step 1 is to factor completely. Okay, step 2 is to reduce. So my first factor I see in the numerator is an x minus y. Will that reduce to anything down there? Yes, this one. So I have 1 here, so they divide out. Just like that. My next factor is a minus b. Do you see a factor of a minus b in the denominator? No, you don't. You see an a plus b. Okay, those are not the same factors. So you're done. So your final answer is going to be 1 times a minus b is a minus b, divided by 1 times a plus b is a plus b. Okay? All right. So all the factoring you learned in the previous module on the factoring polynomials is needed in here. Okay, number 6. So in number 6, let's suppose you had x squared minus 36 divided by x cubed minus 216. So x squared minus 36 divided by x cubed minus 216. Okay, so let's look at the numerator. Do you recognize what the numerator is? So you have a binomial, a difference sign, a subtraction sign, and that looks like perfect squares, right? So the difference of 2 squares. So that means I can factor the numerator as x minus 6 times x plus 6. Okay? Now look at the denominator. So I'm going to go off to the side. I'm going to write that out. So x cubed minus 216. What do you think? What based on what you learned in the previous module, you have 2 terms. Your exponents are 3. What do you want to check for? Yeah, it's check for the difference of 2 cubes. So remember what we did. So can I fill in these parentheses? So x definitely goes in the first one. Now, if you can't guess right away what number times itself 3 times is 216, use your calculator. So in your calculator, you have a cube. You can take the cube root. So what I would do is okay. So the cube root. See where right above the x squared. I'm sorry. Right above the symbol right here. See it says x root. Okay, that's what we're going to use. So I'm going to say 3 because I'm taking the cube root. Second, and then this right here. See cube root of what was it? 216. Press equal, and you get 6. So it's 6. So 6 goes here. And so therefore, you notice this is a difference of two squares, so I can factor it as a binomial times a trinomial. Remember that trinomial cannot be factored. So I get x minus 6. Remember that's how you factor the difference to cubes. So this will be x minus 6 times x squared plus the product of x and 6, so plus 6x, and then plus the last term squared. So 6 squared is 36. So that goes here. So that is this, okay? So I get x minus 6 times x squared plus 6x plus 36. All right, so I did step 1. So step 1 was to factor. So notice I dealt with the difference of two squares and the difference of two cubes. And so now reduce. So I have an x minus 6 as a factor here. Do you see one down here? Yep, right here. So these divide out. Make sure you cross them out. You put ones in their place. That's important. X plus 6. Do you see an x plus 6 here? No. So your answer then will be 1 times x plus 6 is x plus 6 divided by 1 times this trinomial. That's x squared plus 6x plus 36. Now just remember, you may say, well, why do you try and factor this? Well, remember, when you're factoring the difference or sum of two cubes, remember you factor the difference in sum of two cubes as a binomial times a trinomial. That trinomial can never be factored, okay? All right, so that's number 6. All right, number 7. So let's suppose number 7, we have this. For number 7, we have x squared plus 49 divided by x minus 7. So x squared plus 49 divided by x minus 7. Okay, so if you look at the numerator, you have that binomial. That's the sum of two squares. Can I factor the sum of two squares? No, so I cannot factor the sum of two squares. If you look at the denominator, that's x minus 7. I can't factor that either because that linear factor, the GCF is 1. So do these two, so does the numerator and the denominator have a common factor? No, they don't have a common factor. So then what you would say is this. So depending on what my math lab has for their choices, you would say this. You could say answer. You could say can't be simplified. Okay. Or you could say answer. Sometimes your answer, they want you to rewrite this over. So the answer is, this is already in lowest terms. So that's your answer. X squared plus 49 divided by x minus 7. All right. So notice that this was not factorable. They have no common factors. So x squared minus 49 is a factor. I don't see it down here. X minus 7 is a factor in the denominator. It's not a factor in the numerator. So that rational expression cannot be simplified. Or if it says write in lowest terms, then you could say this as well. Okay, so either one is fine. Either one is fine. Okay, number 8. Number 8, so let's suppose we had this for number 8. We had x squared minus 100 divided by x minus 10 squared. So x squared minus 100 divided by x minus 10 squared. Okay, so notice the numerator, I can factor, that's the difference of two squares. So I can factor that as x minus 10 times x plus 10. The denominator is already factored because x minus 10 squared means x minus 10 times x minus 10. So it may be a good idea to write it out like that. And now you can recognize your common factor. So the next step is to reduce. So the x minus 10s here divide out. Make sure you put ones in their place. The next factor is an x plus 10. There's no factor of x plus 10 in the denominator. Here's an x minus 10. There's no factor of x minus 10 in the numerator. You already took care of that. And so there's your answer. So your answer is going to be 1 times x plus 10 is x plus 10 divided by 1 times x minus 10 is x minus 10. So you must write your answer like this. That's your answer. Okay? All right, number 9. Number 9, we have we have y cubed plus 27 divided by y cubed minus 3y squared plus 9y. All right, so y cubed plus 27 divided by y cubed minus 3y squared plus 9y. So look at the numerator. So how can I factor the numerator? Yeah, it looks like that's the sum of two cubes. So if I go off to the side and I look at it, I kind of deal with it, I'm going to get y in the first parentheses, I'm going to get 3 in the second parentheses because 3 cubes 27. So you factor the sum of two cubes. Remember, it's a binomial times a trinomial. So your binomial is y plus 3. And your trinomial is this squared, so y squared is y squared, minus, so remember it's the opposite sign here, minus the product of y and 3, so 3y, plus 3 squared, so that's 9. And so that goes in the numerator. So I have y plus 3 times y squared minus 3y plus 9. And the denominator is, here I can factor out a 3, right? I'm sorry, I can factor out a y. So I get y times y squared minus 3y plus 9. And notice these trinomials divide out. You may say, well, can I factor? Well, think about it. So remember, you factored the numerator as the sum of two cubes. So you have a binomial times a trinomial. So this trinomial cannot be factored. So then I wouldn't even try factoring this because it can't be factored. In fact, it's the same as this one. So just divide it out like this. That's all you do. Now look at the y plus 3 as a factor. Do you see a y plus 3 down here? Nope. So you're done. So the answer is y plus 3 times 1 is y plus 3 divided by y times 1 is y. And so that's your answer. All right, number 10. Number 10, we have 2x squared plus 13x minus 24 divided by 3x squared plus 25x plus 8. All right, so let's suppose we had that. Okay, so if I factor the numerator, so remember to simplify rational expressions, first step is to factor the numerator and factor the denominator, so factor your polynomials. So in the numerator, the GCF is 1, so I'm going to go ahead, and it's a trinomial, so I'm going to go ahead and do this as two binomials. And so it looks like I'm going to get x plus 8 and 2x minus 3 for that one. So always check. 2x times x is 2x squared. The outer is a negative 3x. The inner is a 16x. So I do get 13x. And then 8 times negative 3 is negative 24. The denominator, when I factor that, the GCF is 1. So I'm going to go directly to the two binomials. I'm going to get 3x plus 1, it looks like, and then x plus 8. So that's the one that's going to work there. So 3x times x is 3x squared. The outer is 24x. The inner is x. So I get 25x. And then 1 times 8 is 8. Okay? So for some of you, though, it may have taken a little bit longer for you to come up with those factors. And that's fine. Okay? The more you do, the more experience you get with factoring, the quicker you become. Okay, so can I reduce any common factors? Yeah. What's the only one you can reduce? Very good, the x plus 8. Now remember, don't just cross them out like this. What goes here? A factor 1. What goes here? Factor 1. Because 8 plus x plus 8 divided by x plus 8 is 1, right? Okay, and I can't reduce the 2x minus 3 because that's a 3x plus 1. So all we got to do now is rewrite the answer. So the answer is going to be 1 times 2x minus 3 is 2x minus 3. And then 3x plus 1 times 1 is 3x plus 1. So that's your answer. Okay, number 11. Number 11, we have, let's see, let me quickly get to it. So number 11, we have 5x cubed minus 17x squared plus 6x divided by 10x cubed plus x squared minus 2x. All right, so I have this rational expression. I want to simplify this. And so to simplify, remember the first step is to factor. Now let me say what some students do, and you got to understand why this is not true. So what some students will do is they'll say, well, I can reduce the 5 and the 10. Say 5 and 5 is 1, 5 and the 10 is 2. You can't do that. You cannot do that because 5 is not listed as a factor. All right, so 5 is part of this term, and this term is part of this numerator. So you gotta write these as factors. So that's why it's important. The first thing you do before you reduce is to make sure you've factored. Okay, so you gotta be careful. So you gotta factor. So the first step is to factor completely. Now I'm gonna say this: if all you had was this, then could you reduce the 5 and the 10? Yes. Because now, if you look at this, that's just one term, and that's a factor, and then you have 3 factors of x. That's one term, and you have 3 factors of x as well. So at that point, you could reduce right away. But that is a term of the numerator, so it's connected with some other stuff, some other terms. So you got to be careful. So, as always, the first thing you should always do is to factor your polynomials. Factor your polynomials. So I'm going to go off to the side. I'm going to rewrite this over so that way I can make this a little bit cleaner. So 5x cubed minus 17x squared plus 6x. All right. So notice that the GCF here is x. So I can factor out an x. So I get x times 5x squared minus 17x plus 6. Okay. And so when I factor this trinomial, I'm going to get, let's see, I'm going to get x, the two binomials, so that's be 5x, x. Last sign's positive, so these signs in here are the same, so they're both negative, right? And then for 6, you can try 3, 2, 6, 1. I think the 2 and the 3 are going to work. So let's put the 2 here, the 3 there. Now let's check it. 5x times x is 5x squared. Negative 2 times negative 3 is a positive 6. Now the outer is a negative 15x. The inner is a negative 2x, and I get negative 17x. So that goes in the numerator. So my numerator is x times 5x minus 2 times x minus 3. Okay, now let's talk about the denominator. So let's look at the denominator. So I'm going to rewrite this over, just like this. So sometimes it helps if you go off to the side and you do all your work. Now in the denominator, I can factor out an x, and I get 10x squared plus x minus 2. And so I'm going to go ahead and factor this trinomial, and let's see what we get. So we're going to get 5x and 2x, and the factors of 2 are 2 and 1, so you know you're not going to put the 2 here, because that would imply you could factor out a 2, which means that this would be divisible by 2, and it's not. So let's put the 2 here and the 1 there. Last sign's negative, so these signs are different, and you want the outer and the larger absolute value of this down the inner to be a positive. So that means that this is going to be plus and this is going to be minus. Now double check it. 5x times 2x is 10x squared. A negative 2 times a positive 1 is a negative 2. The outer is 5x. The inner is a negative 4x. When I add them up, I get positive x. So that goes here. So x times 5x minus 2 times 2x plus 1. Okay, so first step was to factor. So notice there are times when you have to go off to the side and do your work. Okay, now let's reduce the common factor. So notice, how many factors do you see in the numerator? It's very important you know what your factors are. There are 3. One of them is an x, the other one's a 5x minus 2, and the other one's an x minus 3. And there are 3 of them in the denominator, an x, a 5x minus 2, and a 2x plus 1. Let's start with the first one. Will that factor of x reduce with the factor of x down here? Yep, this one right here. So remember, when you cross them out, make sure you put factors of 1 in their place. The next factor you see is 5x minus 2. Do you see a factor of 5x minus 2 in the denominator? Yes, you do. So those divide out. The next factor you see is an x minus 3. Do you see an x minus 3 in the denominator? Nope. So you're done. So 1 times x minus 3 is x minus 3. 1 times 2x plus 1 is 2x plus 1. So that's your answer. Okay? Let's look at number 12. So in number 12, we have x cubed y cubed plus 4y cubed plus x squared z cubed plus 4z cubed divided by xy cubed plus xz cubed. Okay, so that's what I have. So you may say, well, seeing this may throw you off. Don't let it throw you off. You know you're factoring. You spent a whole lot of time in the previous module on learning how to factor. So look at your numerator. You have 1, 2, 3, 4. You have 4 terms. So how do you want to try and factor that? By grouping. So let's go off and kind of rewrite the numerator. So I'm going to write smaller because I don't have much space here. So x cubed y cubed plus 4y cubed plus x squared z cubed plus 4z cubed. All right, so I'm going to group the first two, the last two. In the first group, it looks like I can factor out a y cubed, and I get x cubed plus 4. In the second group, I can factor out a z cubed, and I get x squared plus 4. And notice I'm on the right track because these two groups have the same common factor. That should be x cubed. I'm sorry, I made a mistake here. So that's x cubed right here. That should be x cubed. Let's put x cubed. Okay. All right. Okay, so it'll be x cubed because I wanted these two factors to be the same. So I had to go back and change those. So now I can factor out the x cubed plus 4, right? X cubed plus 4. So I get x cubed plus 4 times y cubed plus z cubed. Okay, so that's going to go in the numerator. So I get x cubed plus 4 times y cubed plus z cubed. So when I rewrote the problem from another sheet, I kind of messed up here. So I had to fix it. All right, now the denominator. So look at your denominator. I don't have to go off to the side and do any work because I can figure that out here. What's the GCF here? Well, the GCF is x. So I'm going to get x times y cubed plus z cubed, right? Okay, so now I factored. You may say, well, that's the sum of 2 cubes, so why aren't you going to factor it further? Okay, so don't go any further. Why not? Why don't you want to go any further? Although you can factor this further because that is the sum of 2 cubes, right? I wouldn't do that. Why not? Because you see it down here. This and this are the same, so automatically they divide out. So don't waste your time factoring the sum of 2 cubes because they're the same factors. You understand? Okay. And then notice I can't factor this, so your answer is going to be x cubed plus 4 divided by x. That's your answer. So it's important you understand that if the factor occurs up here and down here in the denominator, then automatically reduce them out. Even if they can be factored further, don't because you're wasting your time. Okay? All right, because remember, the sum of 2 cubes will be a binomial times a trinomial. Same thing here. That binomial is going to be the same as this binomial. The trinomial is the same as that trinomial. They divide out. All right, so that's number 12. And let's see, we're already at almost 40 minutes. So what I'm going to do is I'm going to end this one here. There's some other problems I want to look at with this, so that's going to be the next lesson, the next video. So we're going to end this one because of our time. And so basically the main goal of this lesson was to simplify rational expressions, and then notice that we use these steps to simplify rational expressions. Okay, so that's going to be the end. That's going to be the end of this lesson.